Hi everyone, this is Zakir and this is the sixth video in our module functions. In this video, we will be discussing how to find the range of any function. Check the previous video where we discussed how to find the domain of any function in the description below. To find the domain, we subject the dependent variable y and then use the rules to find the restrictions. However, to find the range, we subject the independent variable x and then use the rules to find the restrictions. First, let us start with a logarithmic function. There are no restrictions for the range of a logarithmic function. In a logarithmic function, the range is always a real number. So for this function, y is an element of all real numbers. For a function with a square root as shown here, we first square both sides. So y squared equals x plus 2. And then we make x as the subject. So x equals y squared minus 2. And then we find the restrictions. So here we can see y has no restrictions. Y can take any value. So y here is an element of all real numbers. So this is the range of this function. Similarly, for fractions, you make x as the subject and then find the restrictions. So let's take this function y equals 1 divided by x squared minus 1. Then we make x as the subject and get the equation x squared equals y plus 1 divided by y. And we get x equals y plus 1 divided by y whole thing square root. So now we need to find the restrictions. Since there is a fraction, the denominator must not be equal to 0. So y cannot be equal to 0. Since it is a square root, the expression inside must be greater than and equal to 0. So y plus 1 divided by y is greater than and equal to 0. Now see, since it is an inequality, we can't simplify this by multiplying y to 0, because in an inequality, we must make sure that the number we multiply is a positive number. Here we are not sure whether y is a positive or a negative number. So what we do, we multiply the numerator and denominator by y. So that gives us y into y plus 1 divided by y squared. Now y squared is a positive definite. So we can multiply this to 0. We then end up with y into y plus 1 is greater than or equal to 0. That would give us the parameters y is greater than and equal to 0 and y plus 1 is greater than and equal to 0. So y is greater than and equal to minus 1. So these are the parameters 0 and minus 1. So now we know that the parameters are minus 1 and 0. And the final inequality that we obtain is y into y plus 1 is greater than or equal to 0. So for the range less than 1, we take any random number less than minus 1 and substitute it for y in this inequality. So for example, let us take minus 2. So minus 2 into minus 2 plus 1, that is minus 1. So minus 2 into minus 1 will give us plus 2. So plus 2 is actually greater than 0. So we can shade this area of the diagram. And for the range between minus 1 and 0, we take any random number between this range. So for example, let's take minus 0.5 and substitute it for y in this equation. So minus 0.5 into minus 0.5 plus 1. that is plus 0.5 is greater than or equal to 0. So when we multiply these two, we get minus 0.25. So this is false because minus 0.25 is not greater than or equal to 0. So we can't shade this area of the diagram. So for the range greater than 0, we take any random number which is greater than 0 and substitute it into the inequality y into y plus 1 is greater than and equal to 0. For example, let us take 1. So 1 into 1 plus 1, that is 2. So 1 into 2 will give us 2. And 2 is in fact greater than 0. So we can shade this part of the diagram. So it says that y is greater than or equal to minus 1. So we have to shade minus 1. And it also says that y is greater than and equal to 0. But we found earlier that y can't be equal to 0. So we do not shade 0. We leave it empty. So this is our final answer. We can write it as a set as follows. Y is an element of all real numbers from minus infinity to minus 1. Remember square bracket. Union from 0 to infinity. So here we use the normal parenthesis and not a square bracket because 0 is not included. So this is the range of this function. So for polynomials, we have to plot the graph and find out the range. For example, for this function y equals x squared, this is the graph. So here we can see that y has all the values above 0 and the graph does not go below y equals 0. So we can say that the range of this function is that y is an element of all real numbers from 0 included to positive infinity. So that is how you find the range of a function. Now for the tip of the day. When you find the restrictions of a domain or range, I recommend you to first plot it on a number line. Then based on the number line's values, you can write down the domain or range. This method is easy and you can avoid any silly mistakes that students usually make while finding the domain or range. With that, we wrap up this video. Please subscribe to our channel, like our Facebook page and share this video to your friends or to anyone who will benefit from this video. If you have any questions or any topic that you find difficult to understand, please ask us in the comments below. We are always ready to help you. Until then, take care.